Okay, everyone. Today I'm Peter. So welcome to my channel about the compulsory physics. So today we're talking about a topic. So the topic is the development of the motion. Okay, so when we start to talking about when actually we mentioned that if we want to talk in the physics, actually we just focus on the trajectory equation or maybe the trajectory, just the trajectory forms of the motions of the objects. So actually that you might be very confused that if we got to know the equation of the motions, but some people when they didn't have the well maths, so in the past, how can they describe this kind of things? So we can back to about the before about century 300 years ago, and here is some a man called the Aristotle, and he proposed something that he start to talking about he start to find something or find some method to describe, or maybe you can say that how to study the motion of the object. So he thinks that if there is a object with a mass, and he will start to I think the mass will start to moving, and you just when you just push the max, or maybe we can say in the near vision that you causing here is an action. There's an action on these objects. So these rocks or maybe the object will start to moving along. So we call this because that the more action when you action on the object, so the object will be keep going. So if you stop the action, and the object will start to will decrease, will start to decreasing, and finally at rest. So the Aristotle thinks that you must be keep acting or maybe keep pushing. You just keep put actions on the object. So you keep pushing, keep put action on the object will cause the object will start to moving. So it means that you got to do this is keep remain. You just remain put. Remain something. You got to keep putting. You got to keep putting something that this. So this is the Aristotle thinking about that. However, if you just want to, however you if you we're talking about this one, so we can think another thing is that a man called Galileo, and he's about 50-80%, Galileo. So Galileo thinks that you don't have just put action still remain station, remain the action, so they will keep the object moving along the ground. So this is the Galileo thinks about that. So this is the first the people before the centuries, and also the peoples have about the 50 centuries, 60 centuries that the scientists said. So that actually that Aristotle even thinking about it. There's another very famous examples that the Aristotle's thinking that if you throwing a rock or maybe an object from the from the air, and at the rest, and the object will keep the object actually start to drop it, right? And if you drop with the one is at the m, big M, and the small m, actually the max at big M and is larger than the small m, and you will find that the big M will be faster when in the same time. Okay, so he thinks that So the velocity will be in the faster in the same time. So Aristotle thinks that because the heavier, or we think that he thinks that the heavier of the heavier the faster. So we call this property is the heaviness. Okay, so we call this is the heaviness. So actually, but the Galileo didn't think this is right because he proposed another example that he said if this is real, so here will be the big M, and this is a small m. So if we got together, we plug these all together, what will happen? The big M and the small m's will together. So what about that will be faster? Okay, so he think this is ridiculous. So this is paradox. So Galileo start to doing something homework, do some work about on the motion, how to describe the motion. So the first properties or the first concept he proposed that is the inertial. So actually, the inertial maybe some people will feel very familiar because in the Newton series, Newton laws, actually we talking about this one. However, the inertial in this is Galileo's actually we focus on a really interesting part that. So the first will be that if you stop to drop something or maybe you push something from a slope. So when you release something, so when you release a bolt or maybe release a object from here, um, here is a height of the here's a height, here is a height, and start at rest, and the bolts actually will be goes on in the same height of the on the stop. So which means that like this. Actually, when you just draw the balls, this object will be stay here finally, and also stay here finally, and also stay here finally. So the Galileo thinks this is the inertials that what so the meaning of the inertial means that is remained the initial state. Okay, so if you want to remain the initial state, you got to the object just have to find just want to find herself initial states in the different positions. So when we start to talking about motion, actually it start from these all kinds of things. So I will be introducing this later in the later section. Okay, so after we finish up talking about object when we use the naked eyes, we can start to focus on the selection motions. So the selection motion actually that means that there's something in the universe. So in the past, the people, or we call the scientists, focus on the star observations. So he start with some people start to use the selection motion to help us to, if you can predict the selection motion, then which means that if you can predict it well, means that your theory is right. So selection motion actually have lots of scientists focus on these studies. So also the Galileo. So the Galileo actually that he discovered. So he discovers telescope. to find there is some the telescope, and he find the Saturns with the sun satellites. So also that he's focused on the sun spot and the moon, and also the Saturn satellite. So all these astronomy discovery actually help us to help us to enhance the final the astronomy's the studies about all these ones. So we were talking about this in the later section about the celestial motions. So this is our list topics though. So the first one, so the idea is that if you want to find out something, or if you find some regular laws, so you can use the scientific method to observe or propose the theories, and if you can make this can fit anything your observation, so you can use these kinds of things to help you to complex. You can use the data or the observation data can come to your theories. Then people will know that wow, this is a great discovery for our people's studies. So see you next section. So this is our today's topic about the development of the motions. So see you next time.